This is homework 40, graphing absolute value equations. First, plot the vertex, and the vertex is labeled H and then K. Remember, you switch the sign of the H and take K as is. Draw the axis of symmetry, and that's X equals whatever your H value is, so X equals H. And then the graph is V-shaped. If V-shaped, it opens up if A is greater than 0, that means A is positive, and down if A is less than 0, that means A would be negative. So graphing the following equations, our axis of symmetry is X equals, and then the opposite of whatever's inside of here, so X equals 1. Our vertex is the point 1, and then take K as is, so negative 2. So our vertex is at the point 1, negative 2, right there. There's our vertex, we'll label it vertex 1, negative 2. And our axis of symmetry is X equals 1, that's the vertical line. So we'll draw that in. And then our slope is the A value. A is 3. Right there. So A is 3, that means we're going to go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. And now for our symmetrical side, we just count how far away is this from the axis of symmetry. Well, it's 1 unit, it's 2 units, right here, 1, 2, 3 units, so 1, 2, 3 units, and 1, 2, 3, 4, 1, 2, 3, 4, right here. Or you could just go up 3 and left 1, up 3, left 1, up 3, left 1, up 3, left 1, instead of going up 3, right 1. And they should mirror across the axis of symmetry. Our next one, our axis of symmetry is X equals the opposite of that, so X equals negative 7, and our vertex is negative 7, negative 4. So negative 7, 1, 2, 3, 4, 5, 6, 7, and negative 4, 1, 2, 3, 4. So our vertex is right there. Vertex, negative 7, negative 4. I should label this. This is our AOS. AOS is X equals, I'm going back to the other problem, X equals 1, just so we're labeling stuff. Vertex, axis of symmetry. So vertex, our axis of symmetry here is 1, 2, is X is negative 7. X equals negative 7, our AOS, right there. And then our slope, we can see our slope is negative 2 right here, right? So that means we're going to go down 2, right 1, down 2, right 1, down 2, right 1. Go in the other direction, we go down 2, left 1, down 2, left 1, down 2, left 1. And see how it V's down. See our A value. A is negative 2 here. A was 3 here. For the next one, it's a little bit tricky because we don't have anything out here. So this is a plus 0, so our axis of symmetry is X equals the opposite of there, so X equals 4. Our vertex is going to be 4, 0, because our Y value is 0 out there. And our A value, our slope, if there's nothing out there, what can we multiply by to not change anything? Our A has to be 1. That's our slope, is 1. So our vertex is at 4, 0, 1, 2, 3, 4, 0. And so our axis of symmetry, let me label the vertex. 4, 0, vertex. Axis of symmetry is X equals 4. It always goes through here, so X equals 4. That's our AOS. And our slope was 1, so we're going up 1 over 1. And up 1 over 1 the other direction. Our next one, our vertex is at -1, 3, the opposite of what's inside there, so our axis of symmetry is x equals -1. Our A value A is 1 here as well. There's an invisible 1 right there. So we'll label our vertex -1, 3 right here. -1, 3 the vertex. And our axis of symmetry is x equals -1, so that's the vertical line that goes through the vertex. X equals -1, and our slope was 1 right there, so we're going up 1 over 1 again. And up 1 over 1 again. And there's our graph. Oh, we've got more. Alright. There's nothing inside of this, so let me write this over again here. So there's an invisible 1 out front of the x. We can say x minus 0, that's the same thing, or the absolute value of x minus 0, and then the minus 4 out there. So now we can see what's our vertex. Our vertex is 0. Take k as is, so -4. There's a 1 out in front, so our A value is 1, and our axis of symmetry goes through our x value of our vertex, so that's x equals 0. So 0, -4, that's on the y-axis, right? So our vertex, 0, -4, axis of symmetry, what's the line that goes through the origin is x equals 0. X equals 0 is the AOS, axis of symmetry, and our slope again is 1. We'll just have a bunch of 1s. So this way and that way. Pretend I'm going through the correct lattice points. I'm doing a good enough job. Alright, our axis, our vertex here is -2, the opposite of what's inside of there, and 1. So -2, 1 right here. -2, 1. It's our vertex. And our axis of symmetry then would be x equals -2. Draw that in. Vertical line. And our slope here is 2/3, right? So that's up 2, right 3. Up 2, right 3. 1, 2, 3. Up 2, right 3. Good. Up 2, left 3. Up 2, left 3. I think I'm doing that right. Up 2, left 3. Yeah. I can count. There we go. Write the equation of these graphs. So our vertex here is 3, 1. The equation is going to be, well, our slope is 2/3, right? So our A value is up 2, right 3, right? And so our equation is going to be y equals A, right? 2/3 times the absolute value of x minus, this point is 3, 1, right? So minus 3, and then plus 1. And our domain, so the domain is possible x values, right? So what's happening? This line's going to go on and on forever to up, as it goes to the right. Well, is there anything going to stop our graph from moving to the right as it goes up? Not in this equation, no, right? I mean, we can have any number we want to in here and we'll get something out. Same thing as we go to the left. So our domain, our possible x values, is all real numbers. Our range, what are our possible y values? Well, y goes up and down. So what happens as we move to, from the vertex, as we move to the left, we go higher and higher and higher. And then so as we come up from up here, we go down, 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 but then we stop going down. We don't go down any farther. So how would we describe that? Well, our range would be y values, right, that are, what, we're greater than 1, right? Y values greater than 1. Or I should write it the other way. Y values greater than 1. Okay? Our possible, and this is a closed circle, so actually greater than or equal to 1. Our next one, our vertex, negative 2, 3. Negative 2, 3. Let's say our a value, right, is we're going down. Now this is we're going down from left to right, right? We're going down 1 over 1. So our a is negative 1. So our equation then would be y equals a, so negative 1 times the absolute value of x minus, but our x value is a negative 2, so that's why I'm going to write a plus 2, and then whatever our k value is, take k as is, so plus 3. Our domain here, right, x values, this is going to keep on going on and on forever to the left, keep on going on and on forever to the right, so our domain is all real numbers. Doesn't matter what our x values are going to be, whatever it wants to be. And then what about our y values? Well, our y values go on and on as we go down, but then we go up, 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 and then stop right here, and we don't go any higher, right? So that's a y value of what? Y is at 3 here. So our range is going to be y values that are less than or equal to 3. This next point has a vertex at negative 2, negative 1, negative 2, negative 1. So to go from our vertex to the next point, we're going, that's our a value, our slope is going up 1, right 2, so our slope is 1/2, so our equation then is going to be y equals, and here's the general form, right? Y equals a times the absolute value of x minus h plus k. Right, so I'm getting my a value from right here. That was our slope, up 1, right 2. So up 1, right 2, 1/2 times the absolute value of x, and then minus the opposite of what is that, whatever's in there. So if it's negative 2, so it's going to be yx plus 2. Because the general formula is already minus. We're subtracting this. We're subtracting a negative 2 makes a positive 2. And then take k as is plus k. So k is negative 1, negative 1. Our domain, always going to be this with absolute value problems. And our range is always going to be whatever we go to. So y values in this case were greater than or equal to negative 1, because we're going, we're above negative 1. This point, our vertex is 1, 2, 3, 4, negative 4, 0. We're not up any. Our a value, our slope up 1 over 1, so a is 1. So our equation, right, y equals a, which is 1, so 1, I'll write it. If I don't write anything there, it's assumed that there's a 1 there. Because you think of that as distributing into this absolute value multiplication. I can multiply by 1 and not change my equation. And so x minus, and then what's our x value is a -4, so minus a -4 turns that into a +4, and then plus k is +0. I don't need that, so really I don't need the 1 or a +0. Let me put this absolute value symbol back, so I don't need what's in red there. You can write it in, it won't be wrong if you wrote it in, but you don't need it. Our domain, all real numbers, and our range, we're going down to 0, and we're above 0, so y values that are greater than or equal to 0.